All Academy. Always with you.
Hello my dear students, welcome to this online video lecture on fluid mechanics. So in the previous 3 sessions we have discussed the complete fundamental concepts on the basics of fluid mechanics, like simple definition, the properties of fluid, then classification of fluid we have discussed, viscosity, surface tension, capillarity, then compressibility, thermodynamic properties of a fluid. Whatever the basic concepts required and which are there for our syllabus, we have discussed in details. Now in today's session we'll going to solve the numericals based on the topics which we have discussed in the previous session. That is, in today's session we're going to solve the numericals on the properties of a fluid as well as the viscosity, and further remaining other numericals will be solved in the next session. That is based on the surface tension, then the capillarity raise, and compressibility. All those numericals will be solved in the next session, but in today's session we'll mainly concentrate on the properties of a fluid as well as the viscosity. And generally these numericals are asked for 6 to 8 marks in your examination. Okay, minimum 6 marks will be asked and maximum 8 marks will be asked. So generally these 8 marks questions will appear from this viscosity topic. So without wasting much time, let us solve the numericals. Now before that I'll just give you the important formulas. These are the important formulas for the numericals what we are solving in today's session. That is the density, then specific weight, specific volume, specific gravity, bulk modulus, and shear stress. So this formula is for viscosity numericals. Okay, and these all are for property of fluids. So these are basically for the property of fluids. These formulas are used for properties of fluid numericals, and this equation is used for the viscosity related numericals. Now let us solve the first numerical. The first question is it is on the properties of a fluid, as already I have mentioned here. So the properties on the fluid. So the question is determine the specific weight, density, specific gravity of 3 liters of a liquid that weighs 24 Newton. So please note that in this numerical he has given a volume quantity of a liquid and its weight. So we need to identify. The specific weight, then we need to identify the density, then we need to identify the specific gravity. Now before that, let us write down the given data. So I'll write the given data. Now in this one, so what he has given volume, he has given, that is 3 liters. So let us convert this into meter cube. So if I want to convert liters to meters cube, so I need to divide it by 1000. So it is 3 divided by 1000, that will be equals to 3 into 10 raised to minus 3 meter cube. Now another thing he has given, that is W he has given, the weight of this fluid is given, so that is 24 Newton. Now what we need to identify? Specific gravity, specific weight, and density we need to identify. So let us, so already we have given you the list of formulas. The first one is specific weight I need to identify. For the specific weight, so that is denoted by small w, it is a capital W divided by volume. So the formula, that is weight of a fluid to volume of a fluid. So this is capital W. So I will write directly 24 divided by 3 into 10 raised to minus 3. So your answer will be around 8000 Newton per meter cube. So why I have written Newton per meter cube? Because weight is in newtons and volume is in meter cube. So this is your answer. I have got one. Now the second one is the density. Now second one is a density. Now how to identify the density? So density is given by rho. It is nothing but W divided by G. This is small w. Okay, W divided by G. What is G? G is a gravitational constant, that is 9.81. Already we have identified the specific weight. So it is 8000 divided by 9.81. So you'll get the answer around 815.5 kg per meter cube. So why I have taken kg per meter cube, the unit conversion? So it is a kg per meter cube. And the last thing is the third one, that is specific gravity. Specific gravity I need to identify. How to identify this specific gravity? It is nothing, it is denoted by capital S. It is density of a fluid divided by density of standard fluid. So in liquids we consider water as a standard fluid, so its density is 1000. So already we have identified the density, that is 815.5 divided by density of water is 1000. So the final answer is 0.8155. Here the specific gravity is a unitless, because even it is also in a density and it is also density, both the units get cancelled, so it is a unitless. So these are the three answers what we need to identify from the numerical. Now this question is asked for 6 marks. This question is asked for 6 marks in the examination. So how the marks will be distributed? So the 2 marks for here, 2 marks for this one, and 2 marks for this one. So total 6 marks. So this question is asked for 6 marks in your examination. And the next problem statement is, so an oil of 5 meter cube weighs 50 kilonewton. Calculate specific weight, mass density, specific gravity and specific volume. So in this numerical, he has given an oil which is having 5 meter cube, means he has given a volume, that is, let us write down the given data for this one. So here the given data is, so the volume is given, that is 5 meter cube, and similarly weight is given, that is W is given 50 kilonewton. You can convert that into newtons also, that is 5 into 50 into 10 raised to 3 Newton. Now we need to identify the specific weight, mass density, specific gravity as well as specific volume. So this question is asked for 8 marks. Okay, this question is asked marks, 2 each carries 2 marks. Now the first one is what we need to identify? We need to identify the specific weight we need to identify. This specific weight is given by, that is small w is equals to capital W by V. So capital W is already given, that is 50 into 10 raised to 3 divided by volume, that is 5. So if you simplify this one, you will get around 10,000 Newton per meter cube. Okay. And the next one is mass density. Now what is mass density? It is nothing but density itself. Sometime you may get confused. Mass density is something. No, it is a density. So it is given by rho equals to, that is mass density. Mass density is equals to rho, that is given by W by G. W by small w by G. So it is equals to, it is 10,000 divided by 9.81. So 9.81, you will get it around answer 19.363 kg per meter cube. So this is your answer, 10,000 divided by gravitational constant. And the next thing is we need to identify, that is third one, that is a specific gravity. How to identify specific gravity? It is denoted by S. It is density of a fluid divided by density of standard fluid. Here's the standard fluid is in a water. So density is already calculated, that is 1019.363 divided by 1000. So you will get an answer of, so that is 1.0193. So 1.0193 is your specific gravity. And the last term we need to identify is the specific volume. Specific volume. This specific volume is denoted by small v. It is identified by using 1 by W. That is 1 by small w. 1 by W, that is 1 by 10,000. So the specific volume is a 0.0001 meter cube per Newton. Meter cube per Newton. So these are the 4 things we need to identify. So the first one is, so here the 2 marks will be allotted for our correct answer. Here again 2 marks, and here 2 marks, and here for this one 2 marks. So total of 8 marks. So let us move to the next question. The next question is the density of a substance is 2900 kg per meter cube. It is a meter cube. Please make a correction. It is a meter cube. Calculate specific weight, relative density and specific volume. So in this one, so let us note down the given things. So given is, so he has given a density that is 2900 kg per meter cube, and we need to calculate the specific weight, relative density and specific volume. So we need to identify 3 things. So here it is given for 6 marks. Okay, 6 marks. Now what is the specific weight? Now the specific weight is nothing but rho into g, that is gravitational constant into density of a fluid. So density of a fluid already is known, that is 2900 into gravitational constant 9.81. So the specific weight will be, it is 28449 Newton per meter cube. Now similarly, this is the first one. Now the second thing is we need to identify relative density. Please don't confuse with a relative density. It is nothing but specific gravity. Sometimes we say it as a relative density and sometimes we say it as a specific gravity. So which is denoted by capital S. So don't confuse it. It is nothing but density of a fluid to density of a standard fluid. So here density is 2900 and the standard fluid is 1000. So your answer will be around 2.9. So since both are having the same units, so it is a unitless parameter. Okay. Now here is a one answer. This is a specific weight and this is a specific volume. And the third one we need to identify, that is specific volume. So how to identify volume? Specific volume is nothing but 1 by density. So it is a 1 by rho. 1 by rho is already we have identified. It is given, that is 2900. So the specific volume will get it around 3.448 into 10 raised to minus 4 meter cube per kg. So this is also one answer. So here for every correct answer you will get 2 marks here, 2 marks here and 2 marks for this one. So don't confuse with a word relative density. It is nothing but the specific gravity, that is density divided by density of a standard fluid. The next numerical statement is, so the velocity distribution in the fluid flow of a viscous liquid having a mu, that is dynamic viscosity has given mu is equals to 9 poise over a fixed boundary is given by mu is equals to 0.68 y minus y square, in which u is a point velocity at a distance of y from the boundary. Determine the shear stress at the boundary at y is equals to 0 and at y equals to 0.34 meter. Now in this numerical statement, so he says that in a velocity distribution, so it is there. Okay, this is a velocity distribution of a viscous fluid, okay, whose dynamic viscosity is given, that is mu is given, that is 9 poise. So as we already discussed, when it is given in a poise we need to divide it by 10. So it is a 9 by 10. So that will be equals to 9 by 10. So that will be equals to 0.9 Newton second per meter square. Okay, this is the first thing. Now he has given over a boundary, so means the velocity is given, so it is a u is given. So u is given in the form of 0.68 yu minus y square. Now where y, that is y, and two y's are given, that is y is equals to 0, y equals to 0.34 meter. What will be the shear stress we need to identify? So what will be the shear stress when y is equals to 0 and when y is equals to 0.34? So there is a velocity distribution, and this velocity, that is u, this whatever u is there, it is given in the equation form, that is 0.68 yu minus y square. So we need to identify the what is the shear stress. So shear stress means, so we need to identify, that is tau we need to identify, that is shear stress tau is equals to mu into du by dy. So we need to identify this shear stress. So we need to identify this when y is equals to 0 and y is equals to 0.34. So this question is on the viscosity or Newton's law of viscosity. Now, so in this one already mu is identified, known, and we have the y values. So but this u is given in the form of equation. So let us differentiate this equation. So now I will take this du by dy is equals to, that is 0.68 minus 2y. So this is a equation. Now in this equation let us put, so y is equals to 0 and y is equals to 0.34. Y is equals to 0 and y equals to 0.4. So we need to put that equation. Now what is that one? So the equation is du by dy is equals to 0.68 minus 2y. So first one at y equals to 0, that is dou u by dou y is equals to 0.68 minus 2 into 0, it will be 0.68. Similarly at y is equals to 0.34, y equals to at 0.34. Now dou u by dou y is equals to 0.68 minus 2 into 0.34. So it will become 0, that is 0 into 0.34 will be 0.68. So 0.68 minus 0.68, it will becomes 0. Now let us substitute this one. Now at y equals to 0, now tau will be equals to, mu is already identified, that is 0.9 into du by dy at y equals to 0 is 0.68. So tau will be equals to 0.612 Newton per meter square. Similarly at y is equals to 0.34, that is tau will be equals to 0.9 into 0. So tau will becomes 0. So the final answer are, these are the two answers. When y is equals to 0, so when y is equals to 0, we have a maximum shear stress. When y is equals to 0.34, we have less shear stress. So these are the answers. So how the marks will be distributed? First, for differentiating this one, so this question is asked for 6 marks. And for identifying this different du by dy, so we'll get 2 marks. So then again substitution and identifying the values, so we get here 1 marks will be there, here 1 marks, and final answer 1 marks. And for shear stress, identifying the shear stress at both the y values, will get 1 marks. This is how marks will be distributed. Now let us move to the next numerical. So the next problem statement is, a fluid of viscosity 0.3 Pascal second is provided between the two parallel plates which are at 3 meter distance. Find the shear stress for the lower fixed plate if the upper one is moved within a velocity of 3 meter per second. So this is a little bit tricky question. So I'll just read out 1 second. So he says that a fluid of viscosity, there is a fluid which is having a viscosity, So I'll write along with that, I will write the given data. So it is having a viscosity 0.3 Pascal second. It is nothing but Newton second per meter square, and is provided between the two parallel plates. It is provided between the two parallel plates, means the whatever fluid is there, it is bounded between the two parallel plates, one upper one and one lower one. Two parallel plates are there. Now we need to identify which are apart from 3 meters. So I will just show the figure for this one. Here is a figure for this one. So this is a upper plate and this is a lower plate, and lower plate is fixed as it is given. Lower plate is fixed, so I have fixed this plate, and upper plate is moving with velocity. Upper plate is moving with a velocity of 3 meter per second, and these two plates are separated from a distance. It is y is equals to 3 mm. It is separated by 3 mm and it is having a viscosity 0.3 and velocity is given. So I will write u is equals to 3 meter per second. Now we need to identify the shear stress, that is tau is equals to mu into dou u by dou y. We need to identify this shear stress. Now for this one, so since the lower plate is fixed and upper plate is moving, so the y, so du will directly consider, that is tau will be equals to, mu is already given, that is 0.3, u is given, that is 3 divided by dy. It is the dy means, so dy is nothing but y minus 0. This is at 0 and this is at 3 meter. So 3 minus 0, it becomes dy will be 3 mm. So if I convert that dy in meters, so it will be 3 into 10 raised to minus 3. So there is 3 into 10 raised to minus 3. Hope you got why I have taken directly 3. Similarly y. So this velocity, this u is 0 and upper plate velocity is moving with a 3 meter. So du, u will be equals to u1 minus u2. So lower one is a 0, this is a 3. So it will be 3 meter per second du. So this is a 3 and divided by 3 into 10 raised to minus 3. Because it is given in a mm, I have converted that in a meters. I will just simplify this one. So we will get tau will be equals to 300 Newton per meter square. Now this is our answer. This question is asked for 6 marks. Okay. Now how the marks will be distributed? For this figure 1 marks is allotted, because without this one you cannot analyze the numerical. So this one 1 marks will be given, and for the du 1 marks is there, and dy 1 marks is there, and for this one, so he has given 3 marks. So he has allotted a 3 marks. Okay. So let us look into the next problem statement. So it is given as a flat plate having an area of 0.64 meter square slides down the inclined plate at an angle of 30 degree. So it is a small plate is there which is having an area of 0.64 and which is at an inclined position, and it is 30 degree to the horizontal plane with a speed. So this plate is coming down in an inclined plane which is with a speed of 0.35 meter per second. Now a lubricating layer of 1.6 meter cube, a lubricating oil of 1.6 meter cube thickness is placed between the plane and the plate. We need determine the viscosity of a lubricating oil used if the weight of a plate is 250 Newton. So we have identified the given data. Now for this one we need to draw the reference figure so that it will be very easy for us to solve this numerical. Now the reference figure for this one is, I have mentioned it here. Now he says that a plate is given. Okay, so you can refer this figure. a plate whose area is 0.64 meter square. Its area is 0.64 meter square and which is inclined at an angle of theta. So theta is 30 degree, and please note that in some of the textbook they have mentioned alpha. So this is an inclination theta, that is 30 degree. Now, and this plate is moving, this plate is moving with a velocity of 0.35 meter per second. So this plate is moving with a velocity of 0.35 meters square, and in between this plate and plane a lubricating oil is placed whose thickness is 1.6 mm. The thickness of an oil is 1.6 mm, and the weight of the plate is given as 250 Newton. The weight of fluid is 250 Newton, and we need to identify the viscosity of this fluid. We need to identify what is the viscosity. So according to this problem, there is a plane which is like this, okay, and it is moving with a velocity of 0.35 per second, and the weight of this plate is 250 Newton, and it is area is 0.64. I need to in between this one, so there is a fluid layer in between this plane and plate. There is a fluid layer, and we need to identify the viscosity of this lubricating or a fluid layer. Now, so for this one, so we need to first identify the force, because the weight is given means it is not in a normal plane, it is at inclined plane. So weight will be acting in some other direction. So we need to identify first the force, which is given by weight into the angle of inclination, that is W into sine theta. F is equals to W into sine theta. So W is given, that is 250 into sine 30 degree. So if you simplify this one, you will get 125 Newton. So if you solve this one, you will get a 1 marks. So this is very important. To identify the force, it is very important, and this question is asked for 8 marks. Please note that this question is asked for 8 marks, and this is a 1 marks, you will get it. Now the next one, so the shear stress can be identified by using shear stress is equals to force by area. Now force we have identified, that is 125 Newton, and area is given, that is 0.64 so meter square. So you will get a shear stress. Now the shear stress will be equals to 195.312 Newton per meter square. Again you will get a 1 marks here. Okay, now we have identified the shear stress, but our actual aim is to identify the viscosity of a fluid. Now we know that the viscosity of a fluid is given by how? What is the equation? Tau is equals to mu into dou u by dou y. So again we have to identify the du. Now du is equals to, now plate, only one plate is moving, that is which is moving at a velocity of 0.35, and the rest one is 0. So it will be, du will be 0.35. Similarly y. So y means it is nothing but the distance between the plane and the plate. So the thickness of lubrication is given, it is nothing but the dy. So it is nothing but thickness of a lubrication oil. So it is how much? It is 1.6 mm. So we need to convert into meters, that is 1.6 into 10 raised to minus 3 meters. So now we have got the du and dy. So here to identify this one, again you will get a 1 marks here, 1 marks here. So total 4 marks. Now the final answer we need to calculate it, that is tau is equals to mu into du by dy. So for this equation 1 marks will be there. Now the shear stress we have already identified, that is 195.312 will be equals to mu we need to identify. Du is already we have calculated 0.35, and y is 1.6 into 10 raised to minus 3. Now if you simplify this one, you will get mu is equals to mu is equals to 0.8928 Newton second per meter square. Now this is our final answer. For this one, 3 marks will be allotted. So in some examples, so they ask identify the viscosity in poise. So if you write this one, you will not get the final complete marks. So it is in a Newton second per meter square. So generally, if the poise is given, if you want to convert into newtons, we will divide by 10. So if you want to convert into poise, we should multiply with 10. For that one, so just 0.8928 into 10. So you will get it. So you'll get 8.928. So for this is for your reference. Okay. It is in poise. It is in poise. It is in Newton per second. Just multiply this answer with a 10. You will get in terms of poise. So this is how the marks will be distributed, and this is how we need to calculate for inclined plane. In an inclined plane, first we need to identify the force. That is very important. To identify the forces, that is very important. Then the next step is to identify once you identify the force, the next step is to identify shear stress. Okay. After identifying the shear stress, the next step is to identify du and dy. After that, the next step is to calculate the viscosity. So this is the 4 steps you need to remember. Understood? And one more thing, if you are multiplying, if you want to take directly this angle, take a sine. Okay, in some textbook they have taken cos, so they have minus, they have taken this inclination. So in that condition you need to take cos this 90 minus this angle 30. So it will be cos 60. If you take cos, just take cos 60, that is 90 minus 60. Okay, if you take on this plane. So hope you are now clear with this inclined planes. And in examination, most of the questions are asked on inclined planes for 8 to 6 marks. If you cross check all the numericals, most of the numericals are asked on this one. The next numerical is on a shafts. So let us see, this is also one of the different numerical. So a circular shaft of diameter 30 mm is rotating in a journal bearing of length 20 centimeter. The speed of a shaft is 3600 rpm. 3600 rpm. So the clearance between the shaft and bearing is 0.6 mm and density of dynamic viscosity is 0.2 Newton second per mm square. 0.2 Newton second per mm square. Determine the torque and the power required to rotate the shaft of at a given speed. Now this is a little bit different numerical when compared to all other previous examples. And this question is asked for 8 marks in your examination. This is for 8 marks. Okay. Now, so he says that there is a circular shaft which is rotating. So which is rotating in between the rotating in the journal bearing of a length. So he has given the length of journal bearing. So this length he has mentioned. So it is not length of a shaft, it is a length of journal bearing. Please note that it is a length of journal bearing 20 centimeter. And the shaft is rotating at an RPM. So I'll write at the same time. Diameter is given 30 mm. Then length he has given 20 centimeter. So you just convert these values, 30 into 10 raised to minus 3. And here it is 20 into 10 raised to minus 2. Then the thickness he has given. So the clearance is nothing but this value he has given. The clearance is around how much? 0.6 mm. So that is 0.6 into 10 raised to minus 3 meters. And he has given dynamic viscosity mu, that is 0.2 Newton second per meter square. And he has also mentioned the speed, that is n. He has mentioned n, that is rpm, that is 3060 rpm. It is rotating as 36 rpm. Now in this one we need to determine the torque. We need to determine the torque and we need to identify the power required. Okay, so not only this shear stress and along with that we need to identify the power and the torque. For this one, so how we identify the velocity or the velocity of a shaft in a shafts? So it is given by u is equals to pi dn by 60. Okay, pi dn by 60, where pi is a constant, that is 3.147. Then d is the diameter of a shaft, n is a rpm of a shaft, and 60 is a unit. So it is a pi into diameter is 30 into 10 raised to minus 3 into n is 360 divided by 60. If you simplify this one, you will get u is equals to 0.5654. So you will get a u is equals to 0.6564. Now we have got the velocity of this shaft. So whatever it is rpm. Please note that this is a revolution per minute. This is not our velocity. So now we have identified the velocity. Now the shear stress is given by tau is equals to mu into du by dy. So now we have identified the velocity and we know the clearance and we have the viscosity. Now we can easily identify the shear stress. Viscosity is a 0.2 and the du velocity is 0.5654 and the clearance is given, that is 0.6 into 10 raised to minus 3. Now the answer will be, if you simplify this one, you will get an answer 188.466 Newton per meter square. Now this is a one more answer. This is a one more answer, that is a shear force. Okay, now we have got a shear stress. Now we need to identify the force. Okay, now we need to identify the force for this one. Now force can be given. Now the force can be, that is F is equals to shear force into area. Shear force into area. That is F is equals to shear force. We have already calculated. Area is pi into D. So shear force is how much? 188.466 into pi into D. That is diameter is 30 into 10 raised to minus 3. Length is how much? Only this much we need to consider. That is into 20 into 10 raised to minus 2. If you simplify this one, you will get a force of 3.552 Newton. 3.55 Newton. So now we have got the force. Now the torque required. Now the torque required to turn this shaft will be given by, the torque required to turn this shaft is given by T is equals to F into D by 2. Why I have taken D? Because this is a shaft, so we need to consider half. So it is given by, now force is 3.552 into diameter is 30 into 10 raised to minus 3 divided by 2. Okay, you will get torque T is equals to 0.00538 Newton meter. So this is a torque we have identified. This is a torque we have identified. The next, we need to identify the power. We need to identify the power. Now power is given by 2 pi n t divided by 60. This is the equation to identify the power. Now 2 is constant, pi is constant, n is shaft revolution, then speed, then it is a torque is 0.05328 whole divided by 60. Now if you simplify this one, you will get P, that is power, you will get it around 2.008 watt. It is in watt. So this is our final answer. Now here 2 marks will be allotted, here 2 marks will be allotted. For force 1 marks will be given, and for torque 1 mark, for force 1 marks will be given, total 5 marks. In remaining the 2 marks for velocity and shear stress. For velocity and shear stress another 3 marks will be allotted. So So hope you have understood all these numericals, whatever we have discussed in today's session. So today, as I said, we have discussed the numericals on the properties of fluid as well as the viscosity. Again, in viscosity, we have solved simple parallel plate viscosity numericals with a parallel plate, inclined plate, and the shaft. If you want to solve more number of problems, already I have uploaded uh, the solutions for all the previous year question paper appeared numericals in the blog. You can download it and you can solve them. And still, if you are having any doubts related to these numericals, you just comment it in a comment box. Or if you want more number of numericals to be solved in this one, you just mention it, and I will try to solve the more number of numericals and will post the videos in our channel. And in the next session, we'll going to solve the numericals on the surface tension, capillarity, then some other related numericals which are appeared in the previous examination, and also we'll see how the questions will be twisted in the same question. Because we have seen that the same number of question papers are repeatedly asked, the same questions have been asked, only the sentences are reframed. So in that case, how need to solve those? So that we'll discuss in the next session. So still, if you are having any doubts, please comment it in a comment box. And if you like the video, kindly share to your friends also. Let them also learn these numericals very effectively in this situation.
Click on subscribe button and press the bell icon to get updates from All Academy.
And even I have solved more than 10 to 12 numericals on inclined numericals, which I have already uploaded in my blog. You can download it. And in that one, I have uploaded separate PDF for the numericals. Around 40 numericals I have solved based on purely on the first module, which are appeared in the previous examination. Almost all the numericals I have solved it. 40 plus numericals are there with including solutions. Okay, you can easily download it, okay, from that one, and you can solve more number of problems by referring that one. So let us move to the next one.